exploration, an investigation. So just a couple of things here. In our little table. So an obtuse angle is bigger than 90. Let's go with 100 degrees. What is, and you guys haven't done this before, okay? Because I know in grade 10, everything was either 90 degrees or smaller. So once my calculator's in degrees, I want to go, what is the sine of 100? Okay, and that's going to give me a ratio. It isn't necessarily opposite over hypotenuse, because that kind of only makes sense if we have 90-degree angles. Okay, so that is the sine. I just want to go 4 digits, so that's 0.9848. Okay, so that's some ratio. What does cosine theta give me? Cosine of 100 is a negative. That might seem kind of weird, but it's fine. Minus 0.1736. Okay, and what's the tangent ratio of 100 degrees? Minus 5.67. That's distracting. Okay, so that's it. That's our 3 primary trig ratios for something that you haven't done before, an obtuse angle. This is just 180 degrees minus whatever angle I'm talking about. What angle am I talking about? 100. So what's 180 minus 100? Okay, and now I want to go sine of 180 minus 100, which is just sine of 80. And this we've done, but you don't remember what it is, of course. What is the sine of 80? Who said oh. Let's continue on. What is the cosine of 180 minus 100 degrees? Or cosine of 80 degrees? 0.1736. Does that number ring a bell? And let's do the tangent of 80 degrees. Ooh. So, if we're good students, we should be maybe engaging ourselves and maybe seeing what the heck's going on. Again, this is just an exploration. I could have just gave it to you and said, you do it, and then, you know, put in a worksheet and say in the bottom, well, what do you notice? Blah, 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 blah. So let me ask, what do you notice? Hang on. Don't yell it out. Don't yell it out. Don't yell it out. Okay. When I took sine of 100, I got that number. So Braden, where else do I see that number? Yeah, that's the same thing, isn't it? And did you guys know purple and yellow make red? Yeah. Now you do. So that was the same. Now, you can't say that for cosine, can you? But the numbers are the same. It's just the sign was different, isn't it? This was minus 1736. This was the same number, but now it's positive. And did the same thing happen for tangent? Negative 5.67. When I take 180 minus that angle, it's positive 5.67. So let's just do one more. Let's say, nice number, 120 degrees. Let's take the sine of that. And I get why did it come up twice? That's weird. 0.8660. And let's jump right on over to this column. Any predictions of what the sine of, what's 180 minus 120? 60. Any guesses as to what the sine of 60 is going to be? You think? Could it be? Could it be? Yes, it could. Huh? What? Sine of 120 is 0.866. The sine of 180 minus 120 is 60. What's the sine of 60? The same thing. Okay? That's the pattern we're trying to create here. Cosine of 120. What's that? Negative something. How about negative 1/2? Any predictions on what cosine of 180 minus 120, that's 60? Any predictions on cosine of 60? Positive or negative? God, let's have a look. Cosine of 60. It is 0.5. Positive. And tangent of 120 is negative 1.73. Any predictions on what tangent of 60 is going to be? You think? Could it work? What do you think? Do I need to do 77 more of these, or do we think we see what the pattern is? Yeah, it's the same, but with a different sign, or what we say is opposite sign. Cosine negative 1/2. If I take 180 minus that angle, it's the same number, but opposite sign. Okay? And I didn't write that in there. That's 60 degrees. Okay? So on and so on and so on. 2's enough, right? Move on. What did we discover? Let me write it for you. We patterns, or as my wife likes to say, patterns. Don't ask me why. So any obtuse angle theta is going to be the same thing if I take it and subtract it from 180. Okay, that's what we saw, wasn't it? If I had 100, and if I subtracted 100 from 180, I get 80, and the sine values were the same. You think that's going to work for 130 degrees? Think it's going to work for 160 degrees? Yeah, it does. Okay, take my word for it. So that's the easy one. This one's just a little trickier, but you see the pattern. Cosine of theta. Michael. Up here, please. How do I write this? It's not exactly the same. It's just with a minus in front, right? Because remember, if I have a minus 3, and if I want that to be equal 3, what do I do to this to make it be equal to that? Is minus minus the same as a positive? Yeah. So that's all I got to do. Go minus cosine of 180 minus theta. And then, like this guy here, negative 0.5, if I want to be that the same thing, I'll just put a minus in front of it, and then it'll be minus minus is a positive. And that is the same as tangent. Okay, cosine and tangent are the same in that respect. Just put a minus in front of it. Okay, and you will get that value. Okay, so that's a handy dandy little table that's in the green summary box, excuse me, on page 163. I'm not going to give that to you on a test. You got to kind of stick that in your noodle. You just got to know sine it's going to be the same thing. And cosine, just take the negative of it. It's the opposite sign, same with tangent. Okay, so some questions we're going to give you, okay, would be like this. Is this true? Sine of 40 is equal to sine of 140. Is that true or false? What do you think? Well, what did we do here? Sine of 100 was equal to that. If I took 180 minus 100, that would have been 80, and the sine of 80 was the same number, right? So what's 180 minus 40? (180 minus that angle theta). Is this the same as this? Yeah. Is this the same as this? It is. It's true, right? Okay, that tells us that. So you don't need to put it in your calculator to verify it, but you could. So let's look at another one. Sine 60. Is that equal to sine 160? Someone says no. It isn't, right? Because what's 180 minus 60? It's 120. Sine of 60 is equal to sine 120. It's not equal to sine 160, okay? That's false. Now, are we allowed to do this? Sine of 60 is that sine of 160 is that. They're definitely not the same, are they? Okay? But you shouldn't need to do that. You should know by looking at it whether that's true or false. Okay, so let's say that's B. Let's look at another one. Cosine 50. Okay, because sine's the easier one. Cosine's a little trickier. Cosine of 50, is that equal to cosine of 130? No, it's equal to negative cosine 130. Okay? It's not equal to positive cosine 130. That's false. How about cosine 20? Is that equal to negative cosine 160? It is. Yep. Let's check it out. Cosine 20 is that. Okay, if I go, I think I can put it in like this. And that's the problem, right? Are you able to put it in your calculator properly? Those are the same, aren't they? Okay, but you shouldn't need to do that. You should look here and know cosine of any theta, 20, is equal to the negative cosine of 180 minus 20, which is 160. That's true. Okay? So that's one style of question we'll give yous. How about another one? Determine two angles that have a sine ratio of 0.5. Trig terminology. Well, let's turn the clock back to grade 10. I wouldn't have asked you two angles. I would have asked you one angle. What is an angle that gives you a sine ratio of 1/2? Good. So here's an angle theta, right? in grade 10, you would have had a right angle triangle. That would be the hypotenuse. That would be the opposite. That would be the adjacent. Sine ratio of 0.5. Do I know the angle here? No, I don't. But I do know opposite over hypotenuse. How did I say that? Hypotenuse. This ratio is equal to 0.5. Okay? So maybe that's 1 and maybe that's 2. Does that give you 0.5? 1 divided by 2? Yeah. If you don't know the angle, what do you do? Second function, sine. This thing's going all clickety. Second function button, right? If you don't know the angle, but you know the ratio, you can find the angle. That's one angle that has a sine ratio of 0.5. Okay? That shouldn't be like, whoa, I've never seen that before, right? You've all been through trigonometry grade 10, and we've been doing this for a couple chapters now. But what's the other angle? Well, sine 30 degrees is the same as sine of what? Right? That's what this thing says. That's going to give you the same ratio. Sine of 100 was the same as the sine of 80. So sine 30 is the same as sine 150. That's the other angle. Those two angles, I mean there's lots, but those are just two. Okay, that give you a sine ratio of 0.5. Bingo, there it is. I can check it. Now, could you sit there all day long and trial and error things in there to try to get 0.5? Yeah, but that's not the way we want to do it, right? Okay. Last example. Identify angles with equal ratios, and I'll give you a couple of pictures. There's triangle A, B, C. Here is triangle D, E, F. Excuse me. And here is triangle GHI. So again, I could put these in my calculator, but we should know the rule here, okay? First thing I probably want to do is find out what all these other unknown angles are. Because how do I know if it's got equal ratios if I don't even know what the angle is? So this is a question that's really tempting to write it in the book. Don't. Okay, copy these down on your paper. Take 2 minutes. Write them out. Then you can write and draw all over heck like you want. Okay? So, tricky part. What kind of a triangle is this? Yeah, but what two angles are the same? So is this 140? Is this 140? Or do these two add to 180 minus 40? Okay, good. You see that? This is visualization. It's really hard to teach. That one's not too bad. Okay, if that's 40, because this length is the same as that length, this angle is the same as that angle. Okay? That's just visualization. Do you see that? Because if you don't, all I can do is say it again. Okay, that's 40. So these add up to 180. So these two angles have to add to 180 minus 40 is 140. So what's 140 divided by 2? 70 and 70. And 70 and 70 is 140. And 40 is 180, right? Okay? If you can't do that in your head, of course you're going to write it down, right? We've done this before. This isn't the first time. Okay? This one's a little easier. This is a scalene triangle. No sides are the same. No angles are the same. That's 50, 70. What's 180 minus 70? That's 110. Obtuse angle. So what are these two angles? These two sides are the same. Is this 155 here? Is this 155? Or is it something else? Do I go 180 minus 55 and divide it by 2 and those are there? Okay, a lot of you see it. Good. This side's the same as that side. So this angle is the same as that angle. Okay? You see that? So that's 55. These add to 110. So that's got to be 70. Okay? So now I can tell what has equal ratios. Well, obviously, if the angle is the same, it's going to have the same ratio, right? So sine of angle B is the same as the sine of angle G. That's the easy one. Any others that are the same? How about A? Yeah. So I think the book will go sine of B is equal to angle G, and the sine of B is equal to angle A, and the sine of A is equal to angle G. Okay, but why write that out 3 times? If they're all equal, let them all be equal. Make sense? Okay, so your answer might look a little better than the book. I don't know. They just write too much stuff, I think. All right, so those are all the same, but what's new for today? Are there other ratios that are also the same? No. Is there something that's 180 minus 70 here somewhere? Because that would be 110, wouldn't it? And I know the sine of 70 is the same as the sine of 180 minus 70, which is 110. Okay, that's the new stuff for today. So I know this is also equal to sine of angle E. So is that it, or is there other relationships? Is there, this is 40. I don't have another 40, but if I have 180 minus 40, I have an equivalent ratio. Is there 140 here somewhere? No. So there's no more possibilities for this guy. This is 50. I don't have a 50, 55, not close enough. But 180 minus 50 is 130. Do I have a 130? No. 20? Do I have 160 somewhere? No. So that one's done, and I guess that's it for this one. Okay, there's going to be more possibilities in your question in the book. Okay, but you got to check it all out. Okay, that's it. 163, 1, 2 just AD, 3, and 4.